Hello guys, my name is David from Primal Habitat, and today we will talk about ball python genetics, and for that I will need a board. So Sophia, go get the board. So first I will explain how genes work in a ball python. For that I will represent in this board a gene with a circle. So imagine this is a gene, okay? In every gene, a ball python has two alleles, represented by these vertical lines. This is one allele, and this is the other. So, every ball python, when passing their genes to their offspring, they will pass one allele for each gene they have. So, if a python has like 2 or 3 genes, they will pass one allele for each gene. There are 3 types of genetic traits in ball pythons. Those are dominant. Oh, come here, boy. Dominant, codominant, and recessive. There is one other type that I will explain later, but for now we have dominant, codominant, and recessive. What this means? In dominant, a gene only has to have one allele of that gene to be visual. So in dominant, if you have like a dominant allele and a normal, you will have visual dominant. Codominant works the same. So if you have one allele codominant and other one normal, it will show visual codominant. In recessive, works differently. If you have only one recessive and one normal, no visual for that recessive gene, so no visual. When a snake only have one allele on each gene for that specific genetic, we call it heterozygous. So in the ball python community, we call it het. The difference between dominant, codominant, and recessive is one allele shows visual in dominant and codominant, and only one allele in recessive shows no visual. When one snake only has one allele of that genetic in a gene, we call it heterozygous. And if it has 2, we call it homozygous. Okay? In this case, in dominant and codominant ball pythons, when they only have one allele per gene, you will never see the heterozygous description. We only call it heterozygous for recessive, because in recessive, only one allele will show no visual. So you will see, in a lot of cases in the reptile community, snakes described like this, like normal and pied. This means this snake is a pied, but it has only one allele for pied, so it shows no visual. So it is a heterozygous pied. In a recessive ball python, we have to have 2 alleles of recessive to show visual. So all recessive snakes have to be homozygous to be visual. So we have to have 2 alleles of recessive. So recessive will mean visual. And what about dominant and codominant? In the dominant, it makes no difference. If you have 2 dominant alleles, it will make a visual dominant as it has only one allele. But if you have 2 codominant alleles in one gene, you will have a super form. So 2 codominant will bring a super form. And this is a main difference between dominant genes and codominant genes. When a dominant gene, you have two alleles of that gene in the gene, you only have the same as you had only one, because you will see the dominant form. But in codominant, if you have one allele, you will see the normal form. For example, enchi, if this codominant allele was enchi, you will see an enchi. But if you have two codominant alleles for enchi, you will have a super enchi, which visually is much different. So I will try to explain with an example. Okay, let's get three different genetics, one which is dominant, other that is codominant, and other that is recessive. Okay? So let's have a spider dominant, spider which is a dominant gene, dom, an enchi which is a codominant, and a desert ghost which is a recessive. So if I would breed a spider to a normal, I will name the spider S and the normal normal. This snake could have in these genes SN or SS if it was a homozygous spider. But as we don't know, let's assume it's a spider normal, the gene she has, and the normal as normal normal. So when they breed, the possibilities would be SN, 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 NN, NN. So breeding a spider to a normal, we would get in 50% of the cases SN, which is spider visual, and in other 50% of the cases we would have normal. If we had a homozygous spider SS, the probabilities would be S N S N S N S N. So with an homozygous spider, you will know that you have an homozygous one because 100% of the offspring would be SN, which would be spider. So codominant works the same. If you have enchi versus normal, it works exactly the same as this. Okay? The only difference is that N in a gene is different than A. This gene is not an enchi, is a super enchi. So how about I would breed one spider to another spider? If I would breed a spider to a spider, a dominant to a dominant. What is the difference of breeding a dominant with a dominant gene, with the same dominant gene, and breeding the same codominant gene together? So if I would breed a spider to a spider, SN, SN, the probabilities would be S, 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 N, N, S, N, N, N. So here I would have a homozygous spider, it should be het spider, but we only use the het when it's not visual, so we'll cross that, and a normal. A normal, sorry. But here, this snake would be equal to these two snakes. So you would get 75% spider and 25% normal. And there is a difference between bringing together dominance or codominance. In the codominant, you will have, for example, an enchi versus an enchi, which is E, N, E, N. And the probabilities would be the same, would be E, 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 N, N, E, N, N. But in this case, instead of having 75% of chances of having an enchi, you will have 25% chances of having a super enchi, which visually it's much different than an enchi, 50% chances of having an enchi, and 25% chances of having a normal. So there is a difference between dominance and codominance. The dominance cannot produce superforms and the codominance can produce superforms. The only good thing when you have two alleles of the same gene in dominance is that you guarantee that the offspring will all be dominant. And in codominance, a superform will produce all the time the non-superform of that snake, okay? So a super enchi will produce every time an enchi, okay? If you bring together a super enchi with a normal. Why? Because if you have here E, E to normal, in every case you will have E, N, E, N, E, N, E, N, which means enchi. In recessives, this will be different because if you have a visual recessive, it means that, as I said before, it has to have two alleles of the same gene. So if you have a desert ghost and breed it to a normal, you will here know that in the gene you will have two alleles of desert ghost. And breeding it to a normal, it will mean desert ghost normal, desert ghost normal, desert ghost normal, and desert ghost normal, which gives a 100% chance of a normal at desert ghost. So, in summary, one ball python passes one allele for each gene. Each gene has two alleles. Okay? Dominants only have to show one allele of their gene, of their genetic trait in the gene, to show visual. Codominants, the same. Recessive have to show two alleles in the gene of the genetic trait to show visual. Difference between dominants and codominants is dominants, when they have two alleles of the same genetic trait in the gene, do not produce superform, so the visual is the same as the normal form, and codominants produce a superform which visually is very different. Okay, let's make things a little bit more difficult, and I will give you an example of breeding one snake with multiple genes to another snake who has multiple genes too. And don't forget, I have another type of genetic trait which is not dominant, codominant or recessive for the end of the video. But I think it's better first explain this part, okay? So let's imagine I would breed an albino, yellow belly, spider to a super enchi desert ghost. It seems difficult to know what the offspring would be, but it's not difficult at all. So we know that the snake passes one allele per gene. So how many genes has the first snake? The first snake has 1, 2, 3 genes. The first one is albino and is not heterozygous, so we know that has to have 2 alleles of albino in that gene. So we know in the first recessive gene that this snake has, it has to be A in the alleles, meaning albino, albino. The yellow belly is a codominant, so it's not a super, yellow belly could have a super form. So as it's not a super form, we know that in this gene it will have a yellow belly allele and a normal one. And spider is a dominant, so we don't know if it is homozygous dominant or not. So we will assume that is not a homozygous dominant, just dominant. Okay, so we'll have S, N. So that these are the three genes for this first snake. Snake, I will put here snake number 1. And the snake number 2, we know that she has two genes, one for Enchi and other for desert ghost. So we know that Enchi is a codominant genetic trait, and in its case is a super Enchi. So we know that it has two alleles of Enchi to produce a super form, like in all codominants. So we know that the first gene for this second snake will be E, which means super Enchi. And the second one is recessive. This desert ghost is a recessive gene. So we know that it has to have two alleles of desert ghosts. If it didn't have two alleles of desert ghost, it would be called super Enchi at desert ghost and not super Enchi desert ghost. So in this case, the second gene will be desert ghost, desert ghost. So as you can see, we have 5 different genes here: the albino recessive, the super Enchi, the desert ghost recessive, the yellow belly, and the spider. So the offspring will have different probabilities depending on which allele they pass on each gene. But let's do a quick example. So for albino, we have only one snake with albino. So the first snake could pass albino in its alleles, but the second one doesn't have albino, so it will pass every time normal. So for the gene albino, the offspring will every time be AN. So in this gene we know that will be at albino. For the yellow belly gene, we have one allele yellow belly and the other allele normal in the first snake. And in the second snake we have no yellow belly. So this first snake could pass yellow belly or normal. And the second snake will always pass normal on this gene because she doesn't have yellow belly in this genetics. So we could have, in 50% of the times, we could have a yellow belly normal, which would mean yellow belly, or N, which would mean normal. So we don't know if we would get in the offspring yellow belly or normal. So in 50% of the case we can get yellow belly or normal. For the spider, it's the same thing. The first snake has a spider gene, but the second snake doesn't have a spider gene. So the first snake could pass on its allele S or N, but the second snake will pass all the time N. So you could have S, N or N, N. So in 50% of the offspring, they will be spider. In the other 50%, they will be normal. For the super Enchi gene, the second snake has a super Enchi gene, but the first one doesn't have it. So the first one will pass N, and the second will always pass E because she has two Enchi alleles. So we will know for sure that the offspring will be EN, so Enchi. And in the desert ghost gene, for the final gene, we know that the first snake will always pass normal because she doesn't have desert ghost. But the second one as she is a visual desert ghost and desert ghost is recessive, she has two alleles of desert ghost. So she will always pass desert ghost. Meaning for the desert ghost will be desert ghost N. So it will be the offspring will be at desert ghost. So what do we know here? We know for sure that our snake will have these three like this: Enchi, at desert ghost, at albino. So we know for sure that our offspring will have all the time Enchi, at desert ghost, at albino. But in sometimes they could be spider, Enchi, at desert ghost, at albino. In other times they could be yellow belly, Enchi, at desert ghost, at albino. And in other times they could be spider, yellow belly, Enchi, at desert ghost, at albino. So we have these three probabilities of offspring: Enchi at desert ghost at albino, yellow spider Enchi at desert ghost at albino, yellow belly Enchi at desert ghost at albino, and spider yellow belly Enchi at desert ghost at albino. Okay? Imagine you will want to make a super Enchi desert ghost like this boy. What would be the best sheep option to do it? Let's get to the board. So, the cheapest way to do this pretty boy would be to have an Enchi at desert ghost and another Enchi at desert ghost. This I think it would be the cheapest way because visual recessive genes are more expensive, and in this case we would have a recessive gene but not visual. So the offspring in this case would be two genes for each snake. In the first one, Enchi normal, one allele for Enchi and other for normal. And in the other, we'll have desert ghost and normal because it's not visual. If we had two, we had a visual desert ghost, and here if we had two Enchis, we would have a super Enchi. So for this one is the same. So the offspring in this case it would be for the gene Enchi, it would be E or E N or N E or N N. And let me just put this boy in my neck because I'm not really able to write. I'm not being able to write with him like this. Let's see if it will behave like this. Okay. So for each of these genes, okay, I will have to put him back. So these are combinations for the Enchi gene, and for each combination of the Enchi gene we will have a combination of desert ghost configurations. So we could have desert ghost, we could have desert ghost normal, we could have normal desert ghost, and normal. And this will be the same for this one, so this will be the same for these ones. Okay, so if we would want to get a super Enchi desert ghost, only here was our goal and here. So if you count all the possibilities, would be 4, 8, 12, 16. So you will have 1 in 16 chances with these two snakes to have a super enchi desert ghost. The last combo and the last genetic traits, I promise I will tell you in the end. So now that you understand what is a dominant, codominant and a recessive gene, we have another type of genes. There are allelic genes. The allelic genes are different than the others because the allelic genes are part of a combo. So if you produce two different codominant genes that are not allelic, it will be like an enchi with a yellow belly. You will have the two genes, enchi, yellow belly. But if the two genes are allelic, in this case the Bell complex, which is a blue-eyed leucistic complex, if you have two genes that are of that complex, you will produce a superform, which is a blue-eyed leucistic. So I will tell you some examples. A lesser, Mojave, Butter are part of the Bell complex, the blue-eyed leucistic complex. So if you would breed a lesser to a Mojave, these genes will act in the same locus. So it's like the Mojave and lesser are communicating for the same gene. So instead of you passing two genes for the offspring, like a lesser gene and a Mojave gene, you will pass only one gene, and that gene could be lesser, Mojave, or Mojave lesser. And it will produce a superform, which is a Bell. Of course, that lesser and the Mojave could send not a lesser allele or not a Mojave allele, and in that case you will not produce the superform like in the other codominants. It has to have two alleles of the same type to produce a superform. So in this case, if you have lesser Mojave, in normal cases you will have lesser normal, Mojave normal. If this gene, if this allele sent was normal, no Bell complex snake, okay? So no blue-eyed leucistic. If this one sends a normal, no blue-eyed leucistic. But if this one sends an L and if this one sends an M, you will always have a Bell blue-eyed leucistic snake, only one gene, okay? This is true for yellow belly sparks in the yellow belly complex and other complexes that are out there. But I don't know if it was clear what are allelic genes, but the allelic genes produces a superform like other codominants, but with different genetics because they work in the same locus, okay? Instead of, if I had a yellow belly enchi, they are not in the same locus. It's not possible using an enchi and a yellow belly producing a superform. But if I use the yellow belly and the spark, I could produce a superform. In this case, I'm not sure if the yellow belly and spark are in the same complex. I'm almost sure they are in the yellow belly complex, but I know for sure that lesser and Mojave are in the Bell complex. So lesser and Mojave could produce a superform. They are two different genes, not as the other ones that they have to be two same codominant genes to produce a superform. In this case, the allelic genes can produce a superform too, which is the snake of the air complex. So in this case, lesser Mojave could produce a blue-eyed leucistic. And this is our sentinel who guards our snakes, so she's here doing her job. So guys, that's it for today. If it was a little bit confusing, I will try to make another video or answer your questions in the future to make this more clear. Thank you for watching, and if you have any other questions about snakes or any other reptile, please send us a message. Thank you.